Okay, so let's see if we could do 30 out of 6.1. So we have two functions, and I changed your book's notation just slightly, right? Because they named both their functions y, which is kind of dumb. So I'm going to call this one y1 of x, which is going to be log of 1 over x. And we've also got y2 of x, which is log of x, just normally. Now, some of you said something like, I don't know how to graph log to start with, yeah? Okay, so here's what you do. You'll get your graph of an exponential function, right? And then what are you supposed to flip over to get the inverse? Yeah, you're supposed to flip over the line y equals x, right? So put your hands where y equals x goes. You're in here. Take your picture, flip it over, and put it back. That's the logarithm. You guys all see that? Okay, so there's my graph for log of x. Bam. Now I'm supposed to graph log of 1 over x, right? I didn't know how to do that right off the bat. How could you try? Like, what would you try?
I would just flip it.
Uh-huh.
I would flip it.
Flip what?
Well, I mean, I have the results, I don't know how to do it there, but they're basically, I guess, however you flip that picture to get it to go upwards is the opposite of log of x.
Okay, so you sort of are looking at this and you're thinking, this is minus log of x. But why is it minus log of x?
Because log rules.
Yeah, because apply log rules, right? So really what you maybe you're thinking is, okay, this thing is log of x to the minus 1 power, right? Then you use your log rule about drag the power down. And so you get that this thing is really, like another way to write this is minus log of x. Cool? And so then you go, all right, I'm going to try to duplicate this picture. So this one's regular log of x, yeah? I know, pretty close? Yeah, close enough-ish, right? And then, how do I get negative that?
Flip it upside down.
Yeah, I want to flip it over I want to do a vertical flip, right? So take your plexiglass, do your vertical flip, put it back. What am I kind of dorking up right now?
You want to have the same x.
Yeah, when I flip that thing over, it ought to still go through here, right? Why should it still go through there?
Because it's inverse.
No, not because it's an
Because
inverse.
you haven't
when x is
changed
zero,
anything
it's-
before zero power is
It's
one.
reflected.
Okay, yeah. So we could check a point, but it's also like that's the thing you flipped over, right? So nothing on that's going to change. Oops, and I did a shit job. Shit.
Same.
Okay, so there's my log of 1 over x, which really is, right, minus log of x. So what did they asked me to graph these, and then they asked me to tell them how I obtained one from the other or something?
But they ask how.
Oh, use the properties to explain this relationship algebraically. So where's your explanation algebraically at? Or what's that?
Right there.
Oh, that's right here. That's that stuff. Cool. Check.